Hello, everyone, and welcome to our listeners as well as to our panelists. My name is Antje Danielson. I'm the Director of Education at the MIT, at Massachusetts Institute of the Environment Energy Initiative. We have two moderators here for this webinar today. This is myself and Valentini, who will introduce herself in a minute. Valentini and I are the co-editors of a book that will soon be published by Cambridge University Press. It's called Energy Education in a Transitioning World. It is a guide for instructors. Each chapter in the book will allow instructors to learn more about the programs that the various authors are running, as well as how to evaluate programs. And we hope that this book will really help instructors in the future to implement their educational energy initiatives. Valentini, would you please introduce yourself?
Sure. Hello, everyone. I'm Valentini Pappa. I'm the Program Director of New Academic Initiatives at Georgetown University in Qatar. It is a pleasure to have you, all of us, with us today. Before we officially begin, just a few quick logistics. Please ensure that your microphone remains muted throughout the session. And also, if you have any questions, feel free to type them in the chat box. We will address them during the QA session at the end.
Thanks, Valentini. And now I'm going to invite our three panelists to introduce themselves. Would you please say a little bit about who you are, where you are located, what your background is, and you also published a book, and maybe a few words, one or two sentences about the book that you have published. I think I'm going to give it to Colin first. Colin, would you please start?
Hey, I'm Colin Anderson. I'm speaking from where I live in Perth, Scotland, Perth, not Perth, Australia, but the original smaller and not as sunny one. I've been working in wind energy for about 40 years, originally in manufacturing, but also in consultancy. And I taught a course called Principles of Wind Energy at Edinburgh University for just over a decade. And that led to the book Wind Turbines, Theory and Practice, which the second edition of which came out just before Christmas. I'll just hold it up very quickly so you can see what it looks like, that one. Yeah, that's me.
Thank you, Colin. Serdar, will you please introduce yourself?
Sure. Thank you, Antje. I am Serdar Çelik. I am a faculty in the Department of Mechanical Engineering at Southern Illinois University, Edwardsville. I'm currently in Edwardsville, Illinois. As for myself, the book that I authored is Sustainable Energy, Engineering Fundamentals and Applications. And as for the book, if I were to say maybe one or two things, it just starts with the basics, covering electrodynamics, chemical energy conversion, thermodynamics, fluid mechanics, heat transfer, just as a refresher for all engineering students, and then goes into the conventional and renewable technologies. I guess that would be the brief introduction. Thank you.
Thank you, Serdar. And Nick, would you please introduce yourself?
Yes. Hello, everybody. I'm Nick Jenkins. I'm the Professor of Renewable Energy at Cardiff University. The book I wrote was Renewable Energy Engineering, which I wrote with a colleague, Janaka Ekanayaka, from the University of Peradeniya in Sri Lanka. And the book is an introduction to renewable energy technologies and practice. It's for undergraduate students, and also we hope for master's students who are converting from a non-engineering degree, trying to engage more closely with renewable energy engineering. And there are a significant number of students who want to do that. So really, I think that's me.
Thank you, Nick. So we're going to dig a little deeper into the introductions by asking you what initially inspired you to work in the renewable and sustainable energy sector, or renewable and sustainable energy engineering, and what keeps you going? What keeps you inspired to stick with it? Let's again start with Colin.
It's going back a bit, but I think it must have been back in the late 1970s when the so-called energy crisis hit the industrial world, and we became more aware of energy and the environment. Also, nuclear power was having, there were sort of question marks over 3 Mile Island and stuff like that at the time. So renewable energy was starting to come into the headlines, and it kind of captured my imagination, and I got into it about a year or two later. And since then, renewable energy, because of the growth of it, my interest in it has only ever increased. So it started, yes, about 40 years ago.
Thank you, Colin. And I'm sorry, Valentini, I think you were supposed to take this question,
No
but
worries.
I'll just continue. Serdar, what inspired you? Let us know.
So, first of all, in terms of choosing or deciding to becoming a mechanical engineer, I think this goes back to my family, my grandfather and my dad being in HVAC business, heating and cooling business. So I knew when I was little that I was going to become a mechanical engineer. But at the same time, since my childhood, I also I just cherished nature, all aspects of it. I guess sustainable energy was just a great combination of mechanical engineering and this interest, towards nature. I'm a hiker and I'm a scuba diver, so anything about, mainly the forests and underwater, I'm really excited. I guess it was just a blend of those which led me into this field.
Are you working on marine energy as well, at all?
Not as part of my research. However, in the book, there is a chapter on ocean energy with different categories, mentioned within it.
Nice. Nick, why don't you tell us your story?
Okay, so I graduated in electrical engineering, and I worked for about 7 years basically in transmission and distribution. And I enjoyed that. I spent 3 years in Bangladesh on transmission and distribution. But then the company, they sent me to work on an oil refinery in Venezuela. And I didn't really get on there. People working on oil and gas are not the most sensitive of souls. And so on the way back, I had a very bad flight back. I was kicked in the back by a child all the way from Caracas to London. And at the end of that, I applied for a job at Imperial College, working on wind diesel systems, and it took off from there.
Thank you. I believe we've already hit on some really interesting topics just from going over your over your personal experiences. So there was wind energy, and I heard nuclear from Colin, and ocean engineering, and your personal passion to nature. So this really kind of segues us really nicely into maybe talking a little bit more about the technologies that we are currently sort of like bombarded with, and the different directions that the technologies and innovations are going. I would like to just really briefly recap the webinar is called Renewable and Sustainable Energy, and I just wanted to say that renewable energy, of course, is the naturally replenished type of energy, whereas the sustainable energy is more broad and encompasses and types of energy that will be we will be able to provide indefinitely without harming the environment or harming future generations. Just wanted to kind of like preface our technology discussion with that, because these days there are a lot of discussions not just about renewable energy, but also other types that might not be renewable. So let's kick it off with another question, and that is, where do you see the greatest challenges in the industry since your career began, and where are we today? Let's start with Serdar this time.
Sure, thank you, Antje. So when I take a look at the industry, some of the changes that I have noticed, which comes, of course, with challenges and opportunities, are mainly, of course, the renewable energy technologies. The advancement in the technology is encouraging, and I feel that it's in the right direction. But of course, there is also the public opinion in certain areas. Even though people might be in favor of a technology or the idea of it, there is this phrase, the NIMBY, not in my backyard. They are okay with the wind energy, but they do not want to see a wind farm, in their backyard. Some people are okay with nuclear energy, but they don't want a nuclear power station close to where they live. So there is that kind of public opinion, which might be one of the challenges. Another opportunity that also is a challenge, I guess, is the digital transformation that we have seen in the past 2 decades, probably. Digitalization, on one hand, is great, but on the other hand, again, does it make the whole energy network more vulnerable towards, say, cyber attacks? So I guess that is one challenge. But I would like to maybe add one more thing. This is not about the technology, but this is about us, the humans. I think our consumption behavior changed drastically in the past few decades. And whenever I cover this in class, also with the students, I asked them just to think of how many things that we plugged on the wall, 40 years ago, versus how many things are being plugged on the wall nowadays. So it's not just our population increasing, but our consumption habits are also changing, not in the greatest way. So I guess that is another challenge that we will have to face and deal with. Thank you.
Thank you, Çelik. And of course, that is a global problem too, with some countries developing and increasing their consumption. We have to think about that as well. Nick, I would give you this question if you have anything to add to what Serdar said, or if you want to comment on any of the challenges that Serdar mentioned.
No, I think that's fine. I think there is a big challenge in actually operating an electrical power system with a very large penetration of renewables. And actually, at 1 o'clock today, I actually checked that the British grid is presently operating with 77% of renewables. That's where the electricity is coming from. And wind energy is 51% and PV is 24%. So in terms of looking at what's going on at the moment, rather than looking ahead, I think that gives a fairly clear steer where students need to be educated.
Thank you, Nick. Colin, do you have anything to add, or would you like to comment on Serdar and Nick's?
Well, just to say those are great answers from both. And yeah, here. Are you using GridWatch, Nick? Is that the,
That's it? Yeah. There's, as everybody has websites. So if anyone look, it's GRID WATCH. And that just shows you the British system. Yeah. I'm
Yes.
sure there are similar ones elsewhere. Yeah.
It does. I'll answer specifically in terms of renewable energy technology. I think the big challenge that kind of follows on from what Nick's just said is intermittency. The fact that renewables, you know, a day like this, we're almost all wind energy in Britain. 2-3 days hence might be very little. And I think overcoming that intermittency so that renewables can supply electricity all the time, you know, on demand, is a huge challenge. I think it's one of the most exciting challenges. I think it can be done. And I think if it could be done, then a lot of the political opposition to renewable energy, which is, you know, you see in various parts of the world, would fade away. So I think, yeah, that's one of the great technical challenges, is turning intermittent renewables into a continuous source of electricity.
Valentini, I'm going to give it to you now.
Sure. So definitely there were a lot of topics and key issues that you mentioned, but I would like to ask the question, and I will start with Colin, of what do you see as the hot topic or focus areas for renewable and sustainable energy in your region and around the world?
The hot topics certainly for the engineers and maybe the politicians too, the one I just referred to, intermittency. So how to balance renewable energy, solar, wind, biomass, get them together on the grid to provide stable power. But as we manage to do this more and more, then I think the mitigating the effects of renewables, making sure we're not harming the environment with the new technologies. So recycling wind turbine blades, minimizing the CO2 impact of manufacture, that kind of thing. That's a very pertinent and growing area in its own right.
Great. Serdar, do you like to add your perspective?
Thank you, Valentini. Yes, if I were to split the question into two pieces, in our region, the state of Illinois, or maybe a big chunk of the Midwest in the US here, the hot topics, I would say, would be, well, for Illinois, that's coal. Coal is the winner, you know, here, while nuclear is also big. And then we have natural gas, and there is quite some interest in solar and wind fields. So this is really encouraging, speaking for our region, or Illinois. If I were to answer the second part of the question, on a global scale, I see the hot topics to be, this is my own opinion, but energy storage technologies. I guess this really is one of the, you know, major, in fact, limiting factors also for the rest of the technology to advance. Maybe mainly the battery technologies, or as they call it, the battery wars, you know. And then I would say energy security would be another hot topic. I feel that hydrogen is also one of those hot topics. I think I would list those to be the major ones, in my opinion, on a global scale.
Great points, and I would definitely agree with all of them from my side. Nick, what's your take on this?
Okay, well, I think we've mentioned the intermittency problem of renewables. I think there's an additional problem in Europe of actually getting the grid connections because of public unhappiness with overhead lines. But the other one is slightly in a different area, which is the shortage of engineers. Renewables comes in much smaller units than, you know, fossil generation. And so you have many more projects. You actually have a lot more plant because the so-called capacity factor are often lower. And there is a really very serious shortage of engineers, young engineers.
Great. Yes, you are one. I will definitely also agree with all of your points. Very valid points. Antje?
Yeah, the nice thing about working in energy, or the interesting thing about working in energy, is that the systems are so complex. And I think just from listening to you and the identification of what you think as the hot topics, there's all these connections, right? So what I heard earlier, for example, was that digitalization is an issue, not just in terms of security, but also potentially in terms of energy consumption, with AI coming up and the energy consumption of data centers. We are grappling with a real problem. I was wondering if you could say maybe a few words about, does AI, what do you think about AI potentially supporting the development and innovation in the renewable and sustainable energy area, or will AI be a hindrance or jeopardize our progress in those areas? Let's start with maybe Colin on this one.
I was hoping you would start with someone else on this one, because yeah, for me it's wait and see. I really can't tell. I mean, AI could potentially allow you to design things in a few days that might have taken years to design, if it fulfills its potential. But can it supplant the originality we need in engineering, design, and thought? Let's wait and see. The energy consumption of AI does worry me a bit, and I know if people are wanting to build new generating plant in order just to feed AI systems, and I think, well, that's the wrong way around. I want us to use less energy, but that's yeah.
I have an example before I get Serdar and Nick in on this question. I spoke with a company representative from a company that produces electrolyzers a few days ago. And 2 years ago, this company was very optimistic about hydrogen and electrolyzers. And I had heard that had lots of orders. And 2 days ago, I spoke with a representative of this company, and he said a lot of those orders had been canceled. And in fact, there was an increase in natural gas turbine orders now, because data centers will now be paired with natural gas. And I heard similar sort of predictions about potentially pairing data centers with small nuclear facilities. Serdar and Nick, do you have any ideas or predictions or concerns around this topic?
I guess I feel like Colin on this one. I see some people to be pro AI and some people are anti AI nowadays, and there is this neutral group. I guess I am also in that neutral group now, waiting to see, observing, and I was thinking of it actually just recently, that AI in human ages is almost like, maybe to me it's like a 6-year-old kid right now. So we have no idea what kind of a teenager it will turn into, So, I mean, we'll have to wait and see. It keeps learning, yes, but again, I think there is still quite some questions, about it. I laugh at it sometimes. My mom, she had a smart thermostat, and she was complaining about it. She says, this thing decides for me what the temperature should be at home. So she finally, asked us, to change it. So we went back to the traditional thermostat. So I think people have different takes on it, but we'll wait and see. I think it's too early maybe to speak about the consequences yet. Thank you.
Yeah. Nick, anything to add to this?
The only thing I think is just reflect on this idea now that infinite growth is somehow acceptable and a good idea. And clearly, coming from the you like, the generation I come from, infinite growth is clearly potty. And now there's this big, I think, philosophical debate, if I can use that word, between those people who think exponential growth can go on forever, particularly in energy consumption, and those of us who take a dramatically different view. And I am appalled by the idea of, establishing nuclear power stations next to data centers just to process some AI.
Yeah. Valentini, do you have a question that you would like to answer to add to this topic? Oh, you're mute.
Okay, so on that one, I would like to add what role will short and long-term storage take. So, and maybe, we can start with Nick.
Okay. Well, clearly long-term storage, is extremely desirable, but in fact, most of it at the moment comes from pumped hydro, and that has serious environmental impacts. Getting permission to build a new pumped hydro scheme will certainly in the UK, well, if there are suitable sites, getting the permissions will take 8 years. So I just think it's really very difficult. I think the only insight I think I've got on long-term storage is that if you want to make electricity, you need a high speed and a reasonably low torque, because that gives you the high air gap speed on your generators. And many of the innovative solutions one sees and one gets asked about are actually high force, if you like, low velocity. And trying to make electricity from that is really very difficult.
So true.
Can
you give some specific examples? We had a question.
Well, the gravitational enthusiasts say, you take a very large weight somehow and you drop it down a distance, but you drop it down really quite slowly. So you've got to accelerate that motion through a multi-stage gearbox, and that gives you immediate problems. So I do have this prejudice, I have to say, that I like high air gap speeds, because I'm an electrical engineer, and that's what makes an easy generator to design.
Just to add to this question, Valentini, any thoughts on sodium or flow batteries, all those ideas that are flying around right now or research work actually on long-term storage innovations?
I did in the new edition of my book, in the final chapter, I looked at the cost of adding storage to renewable energy systems to see what the total cost of energy is if you assume that the storage is part of the solution. So you have to cost that along with your wind farms or your solar farms or whatever. And the conclusion I've come to at the moment is that all forms of storage, especially long-term, are expensive. And that it's actually cheaper to over-install renewable generation so that you have more than you need and you curtail it than it is to add storage in a lot of cases. And if you do that, I mean, you still need storage, but if you over-install by a certain amount and you mix with your renewable sources, you can minimize the storage requirement to a level where it starts to look maybe feasible, a few days rather than a few weeks of storage at a national level. And I did some very, very basic calculations based on national energy profiles or electricity profiles. But it's an area that interests me greatly because I think it can be done, but massive long-term storage technologies, I agree with Nick on this one.
Serdar, do you have anything something to add to this?
Yeah, maybe very quickly. When we look at these energy storage technologies, there is like a number of them out there. And Nick mentioned earlier the pumped hydro. Of all these, if I recall this right, pumped hydro makes up about 95% of the whole energy storage in the globe. So that by itself takes that portion of it. The other 5% is split between so many different energy storage technologies. So I think in one way it can be encouraging that there's quite some room for improvement there. Again, Nick mentioned the gravitational example. On the mechanical side, kinetic and potential storage, and then there is a thermal energy storage. I have a thermal fluid background, so the thermal storage systems, I am hoping that there is going to be more advancement in that field, say mainly phase change materials, PCMs. And then there is electrical chemical storage means too. But yes, I guess in the next few decades, we will see more of these technologies taking more from this pie in terms of their distribution.
Yeah. So I think it would be nice to take just a minute to look at maybe the Q&A questions because we're about to segue into education and what do our students need to know. But maybe there are some questions on technological aspects. Do you see one, Valentini?
Yes, we have 3 questions. And I think the one might have been partially answered, but I will start with the first one. In regards to offshore wind energy, the installations are getting larger and larger. What engineering challenges and limits do you see? In particular, the largest turbine blades are now over 100 meters in length. For example, are aeroelastic challenges likely?
Shall I take that?
Sure.
Yeah, I think as turbines get bigger and bigger, the laws of physics say they actually become less materially efficient. So you need to find new engineering solutions so that the weight doesn't just scale up disproportionately. And I think rotor blades will start to feel that at the stage they're reaching. And I don't know how you can make a rotor blade more materially efficient than it is now, because they're very slender, they're made of carbon fiber, but that's taken a lot of evolution to get that far. But to make them even bigger still, we'll need something that hasn't yet been invented, if you know what I mean. Otherwise, safety margins or stress margins will have to be reduced, and I think there's a challenge there with the very big turbines. Yeah, I think that's going to hit a challenging time.
Can I also, I think we still have the time to ask one question for Serdar. So when it was specifically addressed to you, Serdar, I'm based in Germany. In Germany, there is planning to get rid of nuclear power stations. I have family in Turkey. Turkey is working on setting up nuclear power stations. Which country do you think right long term?
Well, yeah, nuclear. Whenever again, as we're kids, whenever we have a football, a soccer injury, we have this trauma. Like, should I play or not? We fall from the bike. We are distant to the bike for a while, maybe. With the nuclear, again, it was a very natural response following Fukushima. I think that was in 2011. There was this natural, pullback response from the countries being cautious against it. However, that didn't last long, because it is one part of the solution, and the stations that are being decommissioned, each country and each station has their own reasons, and some of them are actually, logistic, fundamental reasons. However, I would not really say that one is doing something better while the other one is not. As long as the protocol and the procedures are followed, I guess nuclear energy in its safe forms should stay as one part of the solution. Nice question, thank you.
Shall we proceed with the discussions? So we had great insights for renewable and sustainable energy, and as Antje mentioned earlier, now we will turn a little bit our attention to teaching, because we are, as educators and professionals, we are evolving in this field. Planning also can be very challenging. So it's a question that it's open to all of you, but I can start probably with Serdar on how difficult it is to plan, whether for teaching or professional work, when the energy future is shaped by shifting technologies, government policies, and also you have to add on that the public opinion. Are there specific tools or techniques that you rely to manage these uncertainties in your teaching or your work? So these are specific techniques and tools.
Thank you, Valentini. Yes, like the energy sector is not like thermodynamics or fluid mechanics where the laws remain, and each academic year we teach the same laws in those courses, or heat transfer, let's say. With the energy related topics, so yes, things are evolving, things are changing, but I think I'm just going with the old school method. Just at the beginning of each academic year, I just refresh my lecture notes based on those advancements, and some of the statistics, some data also needs to be refreshed, and I just revise those and prepare for the new academic year. I guess on my end, that's the only thing I could mention in regards to getting ready.
Nick, how do you approach this challenge on your own content?
Okay, I probably pay a lot more attention to what is, if you like, commercially important at the moment, or nationally important at the moment, than the new technologies. The new technologies actually take a really long time to emerge into everyday use. So one actually has about 20 years of sort of looking forward of a technology before they become widespread. I mean, to give an example, I worked on a flow battery 20 years ago, and it was actually, the project was actually cancelled because of the environmental impact. And now there are obviously great enthusiasts for flow batteries, but bringing that technology to, as I say, everyday use really does take a very long time. And I think it's important not to confuse the students with what's likely to be possible in the future and what is really in practice now.
Thank you, Nick. And Colin, what's your thoughts? What's your, let's say, what you have found as effective?
Well, I'd really just add to what the others have said. I think political, electoral cycles can change the emphasis on renewables or sustainable energy every 4 or 5 years, but the teachers and the engineers have to see beyond that, and they have to carry on doing what they think economics and technology are actually pointing to, rather than what yesterday's newspaper has said. So I think stamina is what you need, really.
Stamina, very, very important word that we keep forgetting. So on a follow-up question, and not far away again from the experiential learning and how, you know, we treat energy education, do you have any thoughts or suggestions on digital learning or place-based learning, experiential learning on when you actually teach energy education? Do you have anything that you have used and you have seen as a success story or something that was not even successful? And we can start with Nick.
Okay, well, if I can compare a couple of courses that I've been teaching at Cardiff, I teach quite a large cohort of mechanical engineers who are pretty good, really, but they're in such a big class that really it is just, you know, presenting the material to them. I also teach a class of electrical engineers, which is much smaller, and that allows us to place a much greater emphasis on coursework, and it's much more resource intensive. And we have, you know, a couple of RAs, which are not common in British universities. And as I say, it takes a great deal of resource, but I think we get a different outcome with a smaller class and much more sort of teaching input, which you know is a fairly obvious thing to say, I guess. Yeah.
Wonderful. Yeah. Colin?
Yes, it's because all the digitalization stuff is kind of, well, it's not new, but it's something that I wasn't exposed to when I was, you know, first in engineering or education or whatever. There's so much available and so much information available online. I kind of feel it's fantastic for research, good for teaching, but not as good for teaching as direct contact at the sort of level that Nick was describing. And I think just the ability to have a to and fro discussion with a teacher at the time rather than, you know, after a lecture or whatever is terribly important. And I think always will be.
And Serdar from the other side of the Atlantic.
Sure. I was thinking of an experiential learning example. This was like a service learning activity. Several years back, a group of our students voluntarily worked on a project. This was this is close to our campus. It's about an hour to the east of us. A caring home for people with developmental disabilities. So this place had the building had a very poor insulation. The windows were poor. The HVAC heating cooling units were old. So they did a thorough analysis of how to improve the energy efficiency of this building. And then this, of course, comes with a cost when some equipment and materials are to be replaced. So they came up with a budget, they came up with a plan, they presented this to a group of engineers at a society in St. Louis, which is 20 minutes to our campus. And they did do the fundraising also, and they completed the project. I guess this was a great experience for them. Well, one, from a very, you know, humane perspective, you know, helping such a community, those people, and then two, what they learned in the classroom, they were able to apply it in the real world, including actually finding the budget, and budget is always the problem, you know. So they were very satisfied with the achievement. I guess that is one example now I can think of when you mentioned experiential learning. Yeah.
Wonderful idea. I mean, it's definitely, you know, to be hands-on, it's always more beneficial. Antje, would you like to take over?
Yeah, of course. This is my area as Director of Education. I, of course, think about comprehensive energy programs and what are the comprehensive skill sets that our students have to have when they go out into the world. And my question connects a little bit to what Serdar just said. I think in the course of this discussion, we already talked a little bit about how important political directions are, or policies that various administrations are setting, as well as marketing trends. And how important do you think is it for our engineering students to have sort of like this interdisciplinary understanding? How much do they need to know about policy setting, a little bit of economics? How does computer science play into this over and above the typical engineering skills that we teach them? Let's start with Nick, and then I'm going to ask Colin from his perspective from the professional perspective. What would you like students to see coming out of our institutes? Nick, let's start with you.
Okay, thanks very much. I'm afraid I think my objectives are rather more limited. I think if we can teach them about, and again I speak about renewables, if we can teach them a little bit about the renewable technologies, we teach very much the importance of the renewable resource, because without a resource nothing works. Then we teach them about the environmental impact, and we teach them a little bit about the costs, particularly discounted cash flow, and if the effect that has on your financial projections. And I'm afraid that's as far as we go. And that's partly sort of limited by the amount of time we've got, and partly limited by, if you like, what British students are kind of expecting. So,
thank you. Sort of from your perspective as a teaching faculty, would you like to include interdisciplinarity into your students' experience, or
you do need quite outstanding students to do that well. I don't wish to hurl bricks at anybody, but I think you do need a particular cohort, a particular sort of student to do that well. Because the weaker students will just feel very uncertain as to what's going on and what they're meant to be doing, and they'll get very unhappy.
That's an interesting thought. I actually did not want to go into that direction, but I think it is actually important to think about the different levels of education, right? In the US, we have the community colleges and the practical skill, the trades, all the way to students that will go into research and development in companies. Sort of what's your perspective on this?
Actually, it is a good coincidence that just starting last year, for the first time, I have been teaching a non-engineering course. And the category of this course in our school is called interdisciplinary studies. So, and then the course still focuses on sustainable and renewable energy. However, now in the classroom, I have students from all kinds of fields. We have students, from pharmacy, from business, so all kinds of non-engineering degrees. Hence, it also allows me to have a much wider option to invite guest speakers to our classes who are not engineers by profession. So that actually has been an eye-opener for myself also as an instructor, but for our students as well. Hence, I do also value the importance of interdisciplinary research, interdisciplinary teaching. And I think it helps the students engage with their teams after graduation, because you are not always going to be in a very, heterogeneous environment that everyone around you is going to be the same discipline. I guess it has another side benefit in that regard.
Thank you. Colin, we're a little short on time, so could you maybe very briefly contribute the perspective of a professional? What do you expect from graduates when they come out of school?
I think having a multidisciplinary approach is very important, and if you don't get it at university, you might get it through your career anyway. The risk of being slightly parochial, that the Scottish school system is slightly different from the rest of the UK, in that you traditionally you leave at a slightly earlier age, but with a broader range of subjects, so that you can do physics and maths and French and English rather than majoring in sciences or arts or whatever. And I think that is actually a strength, which it would be nice to see it come through to university level too.
Thank you. Valentini, would you like to wrap it up?
Sure. And we'll just ask the very final question before we open the floor to our audience. When we have a couple of questions on our chat, I would like just one sentence of which one of you. What is the most important piece of advice you would give to students inspiring to work in this field? So, Nick, let's begin with you.
Okay. I think, again, I'm probably rather parochial, but I come back to the fact I think the technology is fun, but it's the resource that determines profitability and its environmental impact that determines whether you can build anything.
Serdar?
I guess my piece of advice would be just focusing on both the strengths and weaknesses of every energy technology, whatever it is, without any bias, only based on science, no bias. And also after graduation, just being aware of what's going on, one in their region and then two in the globe. So those would be my pieces of advice.
And Colin, we will close with your advice.
Just as a sort of throwaway idea, that nothing you learn is ever wasted. And especially when things are going wrong, that's when you often learn the most. So yeah, just keep your eyes open. Yeah.
Well, thank you so much for sharing all your insights and experiences. It has been a great discussion at this point. Antje, do we have any questions? Are you able to see them? I'm able to see a few.
We have a number of comments in the chat, which I think we don't have to repeat because everyone can see them. There are no real other questions other than the three that we have already asked. But I wanted to thank all our panelists for their great insights. And there are a few topics, of course, that we were unable to touch on because of time limitations. One of them, for example, I think was energy efficiency and consumption. I think we probably didn't talk enough about this. So maybe if you want to just very briefly talk a little bit about that, we have 5 minutes left. And if any of you want to say anything about consumption and energy efficiency, I would think that would be a good closing of the session. Serdar, why don't we start with you?
Well, Antje, I'm glad we had time for energy efficiency talk also, because I feel that at the very heart of all these efforts, this investment or on the education side and teaching, it is not renewable energy, but energy efficiency. This is the low-hanging fruit. I am a strong, firm believer that everything should start first with energy efficiency, and then we build up on it with bonuses, which renewable, of course, is a major player. That would be my brief response to this. But I'm glad you brought this up. Thank you.
Thank you. Nick, what do you think?
I fully agree with that. And certainly I think we should all try and integrate that into any teaching on energy. But it is just extraordinarily difficult. You know, history tells us that either technical energy efficiency changes or worse, behavior modification is just appallingly difficult to implement. And well, I think all one can do at the moment is just to emphasize the extreme difficulty of actually implementing these measures. Yeah.
Thank you, Nick. That's my experience as well, even though I do think that it's very important and should be our number one priority. Colin, what about what are your thoughts on this?
Really, just to reinforce what the others have said, the only thought I could add is that it's a lifestyle more than technology, I think, is the issue. And certainly the town I live in, it would be nice if it was easier to cycle around it. It's very difficult, but if you imagine the energy that would be saved if half the cars stayed off the road because they didn't need to drive short distances, that's the kind of challenge we face.
Thank you, Colin. Valentini, back to you.
So I think we are just 4 minutes before the end of our session. I would like to follow up with a couple of thank you notes. First of all, a big thank you to our panelists, Colin, Serdar, and Nick, for sharing your expertise, your experiences, your perspectives. And I think we had a very engaging discussion. I learned so much, even within this 1 hour. I would like also to thank the listeners. We managed to keep 43 of them on their toes for 1 hour, so that was great. And I hope they found our conversation very enlightening for their own work and for their learning. I would also like to thank what I would call my other half, Antje, for being a great colleague and co-moderator for this panel, and the Cambridge University Press for bringing us together here today and put this panel together. I think it was very useful and very inspiring for each one of us. Antje.
Thank you very much. I couldn't add anything to this. That was wonderful. And thank you, everyone, all the panelists, for your very thoughtful contributions.
Thank you.
Thank you.
Thanks.